conference have come here, up to and including our speaker, but excluding myself. So I'd like to welcome Thomas Ballinger, who's going to be talking about terminal whispering. Please give him a big hand.
Excited to just get right going. So we want to learn to do more than just print text with our terminals. So terminals are cool. They can do a lot of things. We use them every day. You probably, yeah, terminals, right? Technology from 50 years ago. It's great. So typically we use them in the kind of call and response manner. I'm going to show here, right? We'll type a command, and then we display that command, and then we see the output of it on the next line, and then we go down even one more line, and we print the next thing. Python works like this. Bash works like this. It's useful, right? You have the scroll back thing where you can see previous things that have happened, but it's this kind of strict set of rules that we sort of follow. That was a get status. We printed stuff out. There were color, which is kind of interesting. We wonder how to do that. And then we have ls here. Ls is a little bit, if you try ls on your own computer, if you've got it there, and try changing the window size, ls output will change. It will decide how many columns to use based on the size of your terminal. So even in this normal session here, we're starting to see some kind of interesting stuff. And this is the kind of thing that we want to be able to do. We want to unlock the secrets of knowing how to find out how wide the terminal is, so we know how to display this stuff. There are some other cooler things like, so that was a normal back and forth, call and response, write something, see it out. But there's another program called Talk that you might see every day, maybe use this every day. Maybe it's just printing all that stuff really fast and going off the screen, but maybe it's doing something kind of different. And then also kind of neat is that this is appearing here, but when I close it, it just goes away like that. So that's not something we could do just by using print, it seems like, right? So we need to know how to do something like that. And then stuff can get more complicated. There's a program called TIG that, I'm going to do it now, yeah, that just opens up this big thing, and I'm changing that with my keys. I can open things up. This is a Git repository kind of history viewer thing. And then it goes away again. So this is kind of like Vim or Emacs, how it just pops up in this almost separate terminal, but in our terminal. So we need to know how to do that. There is a, okay, it just started again. There's a Python kind of graphical debugger, if you're familiar with PDB. There's another program called PUDB, which is sort of a wrapper for it, that gives you this kind of happy, like Turbo Pascal-inspired kind of like full screen debugger thing. And this is really useful. And it's nice to have it there in the terminal. Maybe we could do it in a GUI thing, or maybe it could be like a crazy HTML, or an interesting HTML view. But instead, we have it right here in our terminal. You might check this out. It's kind of useful. It's nice to be able to use. We just set a breakpoint. Now we're going to hop over and kind of, there's a command line down here. We can look at our variables. We can look at the stack. But an interesting way to do this is to have it in the terminal. Here's another thing. This is started over. This is BPython, which is using, yeah, BPython. So this is kind of fun. Again, it's using the terminal as a canvas and kind of painting a picture, right? And we still sort of have that command line, like call and response thing going on, but it annotates it down here, right? So we can do cool things with the terminal, and we want to unlock the secrets of how to do this. Now, in this talk, we're going to talk about mostly just how it works, sort of, and then you'll be able to Google for this later. You'll be able to find the right library later after I point, directions. But just understanding how we communicate with the terminal is going to be helpful for figuring out how to tell it to do these interesting things we're seeing here. But first, we kind of have to do a kind of more useful than accurate little history lesson here. So if the details are wrong, it's about a memory, it's a mnemonic, it's not about accuracy necessarily. So what are terminals? When I say terminal, I'm usually thinking of a terminal emulator, the thing I see in my screen. I don't mean any of kind of these words. I'm talking about this thing, right? You can see that you can't read the words necessarily, but you can see that it's a window in my graphical environment. You can see the little Mac colored icon things there. It's a little bit important because we're going to talk today about Unix terminals, and I don't understand how much of this is relevant to the Windows console. I think not much of it, but I don't understand exactly where the correspondences stop. But actually, so if you are a Windows user, but you have access to maybe PuTTY and you can SSH in somewhere, or Cygwin, you might open that now if you've got your computer up, because in a bit, I'm going to encourage people to type something in their terminals, and if you'd like to be included in that, I'll show the results here too, so you won't be left out. Right, so what do we mean by terminal? It's called a terminal emulator. So what is it that we're emulating? I usually think of it as emulating these things. We're emulating a video terminal. You're imagining a person sitting in front of this thing, and your application, your interactive command line application, can imagine that it's a person sitting behind one of these, and that's sort of the interface that it has. But these were already emulating something, which are these things, which I might call it like an electronic typewriter, or really like a teletypewriter, or a teleprinter, or there's a specific brand called a teletype. These have been around for 100 years. They were used for telegraph things back then. I'm going to read you a little text from this ad for a teletype machine from 1957. This is when they were celebrating their golden anniversary. This company had been around for 50 years already. I'm going to try to go old-timey radio announcer a little bit. So, a teletype printer is a communications device with a keyboard similar to a typewriter that enables you to send and receive printed messages. With it, written word can be sent instantaneously by wire within the office or plant, or clear across the country to a single destination or any number of destinations at the same time. This is really impressive, pretty cool. In today's business world, wait for it, it goes on. In today's business world, in fact, teletype equipment is often more than a communications instrument. It is the basic element of production control systems. Its ability to transmit and reproduce text and punched tape is harnessed for office automation. Oops. It's a really long one, so I have to make it smaller. Whether leased through your telephone company or other communications company, or purchased outright from us, the versatile line of teletype equipment can be tailored to almost any conceivable demand. For further information, contact your telephone company or other communications company and send for a free booklet, The ABCs of Teletype Equipment. Teletype Corporation, Department F7, 4100 Fullerton Avenue, Chicago, 39, Illinois. So this is an ad. The full text is on Wikipedia, if that wasn't your fill of it. But there's a heritage that comes down from these things that our terminals still or they're still at least inspired by. So we're going to look at little ASCII diagrams, because ASCII's great. This is a typewriter, right? You have fingers pressing keys, and when they hit the key, some metal lever moves, and maybe that connects some ink to paper. Right? That's our basic thing we're starting with, but maybe it's actually a teletypewriter. So instead, fingers pressing keys are causing the teletypewriter to send a signal over a metal wire to something in addition to putting ink to paper. Right? But those are still kind of tied. You're still seeing it display on your own screen as well as sending it. Now, in the earlier ones, maybe you don't need that much information to be sent. Maybe the signal is kind of 5 parallel wires, each that are on or off, and you only need 5 wires because you only need 32 different things you could do. So you only need 5 bits, and you're sending telegraph things to your aunt in New Jersey, and this has to get all the way there. Or maybe later on you use more bits of information. But at this point, we're just sending these signals, and then the application can send stuff back. So maybe that application, again, is a telegraph operator far across the country that's typing this stuff back to you, or maybe it's a computer later, once we have computers. Now we're going to look at a more modernized version of this diagram. It's not that different. A keyboard, key presses go to the terminal. Our application can communicate with the terminal by calling read, the system call read. And then we can write stuff to the terminal, and then some GUI stuff happens, and it gets to our screen, and the light hits our eyes. I like this diagram because looking at it, you think, well, couldn't we simplify it further? Couldn't we just say, no, the keyboard sends things to the application, you call read, and you get them. And then when you write bytes, they kind of go straight to the user. But no, they really don't, because this terminal step is really important. There are bytes we can write to the terminal that don't result in GUI stuff happening and sending stuff out. There are things we could read from the terminal that were not typed by the user. There are things you can type that won't ever reach the application, and there's whatever the fourth corresponding thing is. That might happen too. I don't know. So let's start with the printing. So we're in Python, so we're going to replace these with print and input here. But first, let's look at what bytes we can send and what happens when we send them. What bytes can we write and what happens? We've highlighted the writing portion here. And the relevant parts, notice both of these are kind of relevant for this. Well, first we can send ASCII bytes. There's this mapping of kind of meanings to signals that ASCII represents, and we can send those to the terminal, and they're going to display there. This is sort of standardized in the 60s, I think. We're like, we have tons of bandwidth. Let's send 7 bits of information instead of the 5 or whatever we were doing before. Let's standardize, and let's have some control sequences that don't actually show up there, but they do other things. The first of which, so let's look at how to do this in Python. This talk is going to be in Python 3, which means that to write bytes, it's a little bit indirect, because most of the time we want to write text. But here we're writing bytes. So on sys.standardout buffer.write, I can kind of write these things, or I could write some of these control characters. Some of the ones we're familiar with are things like /n, you might know that one. Maybe /t, you're familiar with that one. Otherwise, maybe, if you know some of the rest of the stuff, spoilers, that's what we're going to see next. This is ASCII code chart. I'm going to say that the stuff over here are the literals. If I send that byte, I expect that byte to appear on the screen. But then there's this stuff over here that if I send it, something else might happen. And this is all stuff that must make some kind of sense in the context of maybe telegraphs, or at least teletypewriters, and typewriters, basically. So let's take a look at this here. So it's a little bit, we could just do this in a normal session. We could just have Python and write these bytes out and see what happens. But it's a bit confusing because we're going to send these bytes, and then they're going to be written, but then also the Python prompt's going to come up, and then other prints will happen. So the way we're going to do this is by, over in this window, running a program that's going to listen on a port and just print out all the bytes that it gets. And then over here, we're going to get socket, build a socket real quick, and connect to this server. And now we're going to send some bytes over. That was good. Some more text. Cool. So when you send bytes, they appear here. We can pretend this is our interactive application. We're actually just sending stuff here, right? But what happens if we send some of those more interesting bytes? This one, you might know what happens, right? But it's not a byte that's going to appear. It's just going to go down to the next line. And now we're going to write some stuff. And that's not that exciting. But here's another one called a carriage return. This is what you might use if you wanted the carriage of your typewriter to move from where it is all the way back over, this is for me, all the way back over to the left. So let's try that. Look at that. So now our cursor is over there. So now, right, we could write some other stuff like, hi. Cool. So now we have the secret of progress bars. If you've seen progress bars appear on your command line before, now we can do that, which is terrific. There's a few others. Maybe we want to move kind of vertically. These aren't that important. But these are all things that make sense in a typewriter, right? You could move back and forth, and you could move down. We're not going to move up. Another thing that's relevant is the little ding. I didn't set up the sound because I wasn't confident in you all hearing this and recognizing it for what it was, but you should try this on your own computer. When I send that, thank you, ding, yeah, ding, ding, ding. So this is the little ding, and you can print this character, and you might, if you've not turned it off, because that's one of the first things many of us do in our bash RCs or vim configs or whatever, you could hear that. So that would be cool. All right, so let's continue here. So here's an example of a progress bar. If you want to do this thing, you know how now. You're going to write that thing. Here's an example of doing it, maybe with Python code. Not that much interesting. We're doing some math to figure out how progressed we are. We're going to write this carriage return, write some stuff, and we're going to flush because our output is buffered. And we won't even see that happening. But if you wanted to write something like that, you could. So next up, what other bytes? Maybe our terminal has an encoding. Probably it does. And it's stored in this environmental variable called something, and then Python cleverly kind of looks all around the environment, tries to figure out what the encoding is, so that we can actually write other things like those 3 bytes together, which end up being this, or because it's Python, we can just say write, and we can write Unicode characters, and so we're happy with this. Next up, let's look at some stuff that doesn't make sense on typewriters anymore. It really only makes sense on these things. First one is ANSI escape sequences. So what if we were to write this thing, which we're a little behind, so we're not going to, well, we've got to do it, though. It's so good. So check this out. What if we were to write /x1b, so this is the escape character itself, open 31m, right? And then we're going to write, so nothing happened. Yeah, nothing obvious happened here. But then when I write some more stuff, it comes out in red. That's crazy, amazing. So we've just unlocked the key to, well, not doing it beautifully yet, but at least how to do this red stuff. And there's interesting behavior we just saw, which is that our terminal has state, right? It must have a variable somewhere. It's like, what's my current color? And this works the same way with other things like, am I underlined right now? Is it blinking? All these other things like that. So I'm calling this an ANSI escape sequence because there's a standard where we decided this is the way it works. And here are some other ones. I can move the cursor. I can clear the whole screen. I can hide the cursor. I can start writing these different ways. But there's well, an interesting history here where there were a lot of different terminals that implemented different escape sequences. And so the ANSI, that implies some kind of standards body tried to figure out a standard, which means there must have been a problem before where there wasn't a standard. So analogous to the browser wars of more recently, where you write this JavaScript application, but it doesn't quite work in one browser and it does in another, and maybe you write a shim, or maybe you're like, wow, I wish I could get this to work. Or maybe you're a user and it's 84, now we're back in terminal land, and you log into this really cool BBS system, and on your friend's computer it looks like this, or your friend's terminal, it's doing cool stuff, and then on yours it's not working, it's really disappointing. So there was opportunity here, in the same way that the browser incompatibilities made jQuery a thing that really needed to exist. We have our kind of 1980s jQuery, which is called termcap. And this is a database of all the terminals and which ones, what the capabilities are in each. And in your application, you use that, or really curses, which is this application interface to that thing. And then command line tools like tput. And then now, maybe it's less necessary, but it's still the beautiful way to do this. There's more standardization on how your terminal works, but you still ought to use something like this. We'll skip that. Here's the way you ought to be doing this. This is the thing to take away from this talk, besides that you can write bytes to a terminal, and sometimes it doesn't print them. And that's that if you want to know what bytes to print to a terminal, you ought to use this library called Blessings, which is a wrapper over curses, because it's a pun. Yeah. And this is nice. So now that you know that it's just bytes, you know that this t.bold thing here, that's just saying build a string that turns on boldness, writes hi there, and then turns it off. And it's still your responsibility to print that string. So now you know kind of how to use this blessings thing. Most of it generates strings that it's your job to print. Look at this later. So secrets that we've unlocked by writing bytes to the terminal. We can do colored and styled text. We can have bold, underline, blink. We can move the cursor anywhere. We can use the alternate screen, which is a series of bytes you write that means now we're in that separate thing that you saw Vim or TIG or Top using. We can hide the cursor. We can do a bunch more stuff. OK, now let's talk about input. This is not quite as beautiful a story. It's not just this one secret that will unlock everything, which is that you write weird bytes. Here, instead, we'll look at the different things we can do. Here's some problems you get when you read from the terminal. Normally, you just call read, and you get to read this line of text, and you don't get it immediately, right? Data's not passed the application until the user hits enter or return. You have a little bit of editing, and you can kind of see what editing you have if you try cat, but you don't get it right away. So that's a problem we might want to fix. And echoing back characters is another one. When you hit a character, it displays on your screen because of that heritage with typewriters, right? It hits this paper as well as sending the message. What if we don't want it to hit the paper? So we're going to look at an example with echoing back characters, but this is going to work similarly for everything. The trick here is that this diagram is actually going to be modified. We actually have another way to interface with the terminal. That little thing is supposed to be a little mining symbol. The idea is that there are knobs and dials on your terminal. And on your terminal emulator that you can twist and read and do things with. And we're going to do that from our application. And some of the things we can do are say, stop buffering the input the same way, stop echoing the characters every time. Here are some man pages you could read if you read the slides later. They're long and interesting. If you're doing this command line, you can do it this way, but we're in Python. So we're going to look at this get pass example. This is in the standard library. This is also in the standard library docs, where it's showing an example of the term.io stuff. Don't worry about the code, just look at the shape of it. We are getting some information about the current way that the terminal is, and then we're modifying it, and then in the try, we modify it, we try to do the thing we want to do, and then we have a finally. And this is really important because the terminal is a resource that's really external to our Python program. You really don't want to mess up the terminal for the user. And that happens all the time, right? You have a terminal, you accidentally pipe a file that's binary out, and something weird happens to your terminal, and then you need to type reset, R-E-S-E-T, and you hit enter, and it's still not fixed, so you try it again because maybe you had some characters before that. So this is a good fit for a context manager, something like this where you say, fix the terminal, unfix it. You could use this like this. Now, here are things we want to change and that we can do with this modifying the input that way. We can turn off echo. We can get the keys to send immediately. We can ask for the terminal size. You can say, what size is the terminal, as though it's printed on the side of it. And we can do non-blocking input, which is a little different because it's a file descriptor control thing. But similarly, it's a way to change the way we're getting our input. And that might be important if you're writing a game, for example. Terminal games are a lot of why I'm excited about this. Other problems we might have, well, there's mapping bytes to keys. So maybe the bytes that you read aren't the same as you get A, and it's like, oh, that was probably an A key press. But then you get this thing, and you have to know that that's F11. This is another thing that you want to be aware of, another level of abstraction or of a level in between you and writing, say, a config file where users get to say, I want to hit F11 and have this thing happen. And then really interesting is the last example thing we'll do. Bytes can be sent from the terminal without something being typed. The example here is the cursor query. So you should try this if you've got your computer up. Just try printing this sequence up here. And for the spoiler, what's going to happen is that we're going to print this, and it's going to say that on the next line. Right? There's not, that prompt is there on purpose. It's actually going to ask for input, and then it will have that appear, something like that. Really what's occurring is, is this, but the way your terminal displays that doesn't have the whole thing. And that's because in this diagram here, when you do a cursor query, the application writes some bytes to the terminal, and then the terminal puts some stuff ready to be read by that next read call. This is a thing that doesn't make sense to do if you're not in a non-blocking input mode, but you've asked, where is the cursor on the screen right now? And it writes back, but the way it responds is not a function call or something. It's just by writing those bytes as though the user typed them in. So you have to distinguish between, did the user type this, or is this the response to my query? So this is showing us the terminal really is its own kind of beast. It's its own thing, and it could just generate stuff. We look at this. All right, one more way that we communicate from the terminal to our application are signals. I've kind of abandoned ASCII here and said that sometimes the terminal sends this Unix signal to the application, and you have to deal with this. And you can twiddle the knobs on the terminal to say, don't send those, or send them in these circumstances. These are the kinds of things you might get. This is Control-C, that's Control-Z. This is the window changed, and a ton of other ones. And this is the right time to mention these kind of groups of settings. If you want the terminal to, you want it to turn off echo, you want it to stop buffering your input, and you want it to not generate signals every time you hit Control-C, you might want to use this raw mode. If you want the first two things but not the third, maybe you want this C break thing. So now doing this in practice, these are the tools you might want to use. Blessings is basically the one to use. If something's missing from that, you have to do something special. But it should be your base layer instead of curses, in my opinion. And there's a tool called Urwid we'll look at, which is a more Java-y thing, I've heard it described, but in the best way possible. It's this widget library for building stuff like PUDB. So our PUDB example was written in Urwid. And if you want to say, I wish I had a window like this and then another window like this, and I want to select up and down, then instead of using the basic stuff in the cursors module in the Python standard library, I would use Urwid. There are two libraries for command line stuff called click and clint, and they do some stuff like helpers that you might want in the terminal, stuff like the ls displaying stuff in columns, or maybe doing stuff with color but without taking over the whole screen. We have Curtsies, a library that I wrote that I would be talking a lot more about, except that in the time since I submitted this talk, another library called the Python Prompt Toolkit has come around by Jonathan Blessings, and it's primo. There was a talk this morning, a lightning talk, about a Postgres command line tool someone made with it that's really nice. It does stuff. Someone made a PT Python, this Python prompt with it that's really great. And I don't have time to talk about other random cool stuff, but there's other random cool stuff you could do with this that I'd love to talk about. And unfortunately, I don't have time, so thanks very much for listening.
All right, outstanding job, Thomas. So we have like about 3 minutes for questions. So if you'd like to ask a question, the microphone is in the middle of the room. Please line up there.
Questions? Questions?
So there's just a question from the front here.
Oh, great.
I just opened up my Mac keyboard and tried to type an emoji into the terminal, and that worked pretty well, but then it screwed up the width. Do you know what's going on with that?
Yes, I know exactly what's going on with that. In fact, I wrote a blog post you can read on the recurse.com blog about this. But another concern you have to worry about, that there's a merge request into this Blessings library that Eric, who's sitting in the front here and would probably be happy to take questions afterwards, could talk about. You have to figure out, if you're doing this terminal UI stuff, you have to figure out how you're trying to draw windows. You move the cursor up here and you write this thing, and you move the cursor down here and you write the next row of your window. But you're now, window layout's not easy, and in the terminal you might write a neat little emoji thing, and if you're trying to calculate how wide that might be based on how many Unicode characters it makes up, or based on how many bytes it is, you could have problems. So these things can be more complicated than they first appear, basically, and yeah, I'd recommend that blog post for a full treatment of that. Yeah.
All right, I have a question if no one else does. Thomas, you mentioned you were into terminal-based games. Have you written any that you'd like to plug right now?
I've started a ton, and they're all going to be great someday. But I always get distracted by writing the framework, which is I do instead. The thing that I've worked on is this bpython tool that I had up before. I've done a variety of things with it. Another thing I've worked on recently is this kind of fun undo tool where we'll see if this comes up, but you kind of take over the terminal and kind of repaint it in sort of guerrilla warfare ways to implement. This one won't be undo. This will be, you see the effect here? It's kind of changing the case on everything before here in Python. So there's fun weird things you can do with this. So I've worked on some of those instead.
You're a sick man. Okay, it was a pleasure having you. Thank you very much, Thomas. Give him a huge hand. All right, and we have about 10 minutes till our next speaker. Thanks very much, everyone, for coming to the best room of the conference. We've got the final talk in here coming up next, and that's going to be the best talk of the whole conference for sure.